This.
Hey everyone, how you doing? My name is Rahat. I'm a developer advocate over at Polygon. So I decided to do this workshop a little bit differently. This is the only slide you will see. That's it. Everything else is code. Is that cool? I said, screw it. We don't need slides. We just need code. You guys are hackers. You guys are developers. This is what we're going to do. So thank you for coming to my talk. This is all about taking a Web 2 browser game and turning it into a play-to-earn game. We're going to do something real simple. How many people have played rock, paper, scissors ever in your entire life? All right, so you're aware of the mechanics of rock, paper, scissors. Cool. Awesome. So let me just make sure my code is what I want it to be. Okay. So we got this rock, paper, scissors game here. Just a simple React application. Nothing big, nothing's going on. All right, if you want me to hit rock, please put up a rock. Scissors, put up a peace sign. Paper, put up a hand. All right, see 2 papers, paper, scissor, rock. It looks like, all right, it looks like rock wins. All right, hit rock. Nobody wins. Come on, guys. All right, one more time. Rock, paper, scissors, paper, 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 scissors. Okay. All right, paper again. All right, paper. We lost. Okay, whatever. So nothing huge going on there, right? It's a simple rock, paper, scissors game. This is what the code looks like real quick. I'll show you right now. Components. I call this component Web 2 game. So it's just this gigantic switch case with a bunch of if statements. You know, if, paper, rock, whatever. Somebody wins. And I'm just like putting a bunch of things in state. This is probably not an optimized version of this code. Very, crappy version of it, but it gets the point across, right? We have a rock, paper, scissors game that exists in the browser. Now, what if we wanted to add some elements of, Web 3 into this? So I'm opening this up. I call this the Web 2.5 game. I call it Web 2.5 because all we're doing here, we're slapping the Wallet Connect function onto this. Nothing huge going on. I have this handle Wallet Connect function, pulling the Ethereum object out of the window. What does that mean? As long as I've got a browser injected Chrome extension like MetaMask or something like that, I'll have the Ethereum object, and I can pull that out the window. As long as that all is good, I am just doing a couple, boilerplate stuff of taking the Web3 provider from Ethers, requesting access to the user's account, and getting their address. So let's update that. Let's remove the Web 2 game from in here, and let's add the Web 2.5 game. Wrong thing. Okay. Come on. Doing this with one hand is like the wrong thing to do. Okay, cool. So now we got this Wallet Connect, right? Hit Connect Wallet. Great. MetaMask pops up. Next. Connect. Wonderful. All it took was 2 lines of code, right? Now we slapped a wallet, sign in with wallet. Can anyone tell me what's wrong with this? Just shout it out. Exactly. It's not inclusive because not everyone uses MetaMask. People have mobile wallets. People have hardware wallets. If I wanted to go beyond this and make sure that I'm actually being inclusive and bringing people in, I think there was a workshop earlier on Wallet Connect. Definitely recommend using that instead. But for the purposes of this, I'm just kind of looking at one use case particularly for an injected wallet. But we always want to make sure we're being as inclusive as possible to many different types of people. So for now, all I'm doing is I'm saving this address into state, nothing big. Again, just works the same still a Web 2 game, right? How would I turn this into a Web 3 game? Let's take a look at some smart contract code. So this is very, very, very simple smart contract. There's not a lot going on here. But just to kind of visualize what's going on, what I want to accomplish here is that I want to take this rock, paper, scissors game. I want people to wager some amount of Matic on the Polygon network. And if they lose, if they draw, they lose that Matic. And if they win, they take the entire amount of Matic that's in the pot for themselves, right? So a little bit of a gambling, rock, paper, scissors implementation of a game, right? So how does this work? So I've got the contract, the game. I've got a private string that is going to take care of who the winner is. Actually, I don't think I'm using this, but whatever. This unsigned integer, which is the balance, which is going to keep track of how much money is actually in here. And I've got a few functions. First is this receive money function. It's just to send some money over to the contract. Now, I made this public for one reason. I just want to make sure that, if at any point in time I decide to put this smart contract onto the blockchain or whatever, I can load it up with money, in case. If I need somebody to load it up with money so people can actually earn some stuff instead of winning nothing, So just making that a little bit easier. Using this payable function, Solidity has payments baked in natively. You don't need to import any other smart contracts, anything. Everything is accessible with this payable modifier. So all I'm doing is taking this balance up here, this public balance, and updating it with this message.value. Where do I get message.value from? Whenever somebody uses their wallet, their MetaMask or anything like that, I can extract the value of whatever amount of money they've wagered or put in there and keep track of that value with this message.value. Super useful to know in Solidity. Now I'm doing this get balance function. This might be redundant, but just to kind of give you an idea of how something like this would work. It's just a very plain kind of function, tells you the current balance of the amount of money that's on this contract, right? Nothing useful. Now we get to the fun part, this play function. So literally all I'm doing, I'm still allowing my front end to decide who the winner is, and if they won, if that's true, then I'm going to take the address of the person who is interacting with the contract. So that is available through me again through this message object, but now instead of message.value, I'm doing message.sender, which is going to give me the address of whoever is interacting with this contract, right? Now, I'm gonna take that, and I'm just gonna transfer some money to them. Whatever the current balance is, I'm gonna give them that money if they won. If they didn't win, I'm just gonna call the receive money function up here, and they lose the Matic that they wagered, right? So nothing too over-detailed. A couple things wrong with this. So this is one thing I learned from a talk I once listened to is when you're building anything, you're building a SaaS product, you're building a smart contract, whatever. Your first version of it is probably not going to be the best version of it. You just want to get something working, right? This works. It does, in theory, what you need it to do. You can extract money from someone. If they win, you can give them some money. Originally, I was thinking about doing the whole game engine on chain, which would have taken me more than 20 minutes, so I didn't do it. But so what I would do if I wanted to make this completely on chain. Now, in JavaScript, I'm able to go into an array and just sort of randomly pick out some value, like rock, paper, scissors for the opponent value. In Solidity, you cannot do anything randomly. You can do pseudo-random numbers. There's different methods. But there's no actual way to do truly random randomization or random number generation inside of Solidity. If you wanted to do that, there are some tools out there like Chainlink will give you a verifiably random kind of generated number, things like that. But that has to happen off-chain somewhere, So just to kind of emulate that, I decided to let's let JavaScript kind of handle that part. But if you were to actually go into production with something like this and you want like real random number generation, definitely recommend looking at Chainlink. I do not work for Chainlink. They did not endorse this at all. I just like their product. Just want to make that clear. So we've got this. Let's deploy this. You know, so I've got this here. If I'm deploying from Remix, I go here, compile. Looks like there's no problems. I'm gonna copy this ABI code real quick. Just drop that in here. This ABI.json. Why that's important, I will talk about in just a second. But that's there. And let's go ahead and deploy this. Injected Web3. Cool. This is my test Matic. I don't have this much Matic. I wish I did. But let's deploy this. Hit deploy. My MetaMask pops up, and we'll confirm this. And this is being deployed onto the Polygon Mumbai network. It's one of our test networks for any time you want to, test out your smart contracts, putting things out there. How many people have just worked with Solidity in general, worked on the Ethereum blockchain? Cool, a bunch of you, okay. Doing things on the Ethereum blockchain and on the Polygon blockchain, exactly the same. Every tool that you learn, every, if you use Rahat Foundry, if you use Truffle, if you use a Remix, all of that maps one-to-one. It just takes usually one line of like configuration. If you're using Rahat or Truffle or something like that, all you do is just like change the RPC endpoint from like, the Ethereum endpoint over to a Polygon Mumbai network or Polygon mainnet, if that's what you want. But, at the end of the day, everything is EVM compatible. Everything you learned stays the same. And again, just maps one-to-one. That's why it's like we've been really focusing on a good developer experience. We don't want you to learn anything new just to use another blockchain. Everything maps one-to-one. You'll also, so this is specifically using our proof of stake blockchain, which many people know as a sidechain. That is not the only product that we have out. Today and a few other days, we actually launched a few other things like Polygon Edge. There's a lot of work that the Hermes team is doing as well. And there's a whole suite of products that you can use to like build on top of Ethereum. But yeah, today we're just focusing on our proof of stake blockchain. So that is out. Let me see where that is. Okay, is that in here? Contract deployment. Let's view on Block Explorer. So this is a testnet transaction. Great, it was a success. Everything looks good. Let's actually take a look at this deployed contract. So these are some of the functionalities that I could just like test, before I actually put it into my front end. But hit balance right now says 0, right? So I made that. Remember, I made that receive money, public, just so I can put some money in here. Let's go ahead and put 3 Matic in here. So if you've done any sort of deployment or work on Solidity before, you'll know that like the smallest unit inside of Solidity, in reference to Ether, is Wei. Works the same way on Polygon blockchain. The smallest unit of Matic is also Wei, which is like 1 to the 18th 0 power or something like that. So 3 Matic, that converts over to this much Wei. Let's copy that value and drop it in here. Ooh, okay, so let me just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, that's good enough. Okay, so let's hit receive money. Awesome, I'm putting 3 Matic onto this contract. Confirm, and you'll see like gas fees are like very negligible. Confirm. That's pending. Let's actually go ahead and look at this contract itself. How do I get to the contract? There it is, contract. So this is the deployed contract on Polygon Scan right now. Deployed about 3 minutes ago. Let's just make sure this went through. Looks like it was successful. I'm gonna hit balance. Yep, 3 to the 18th power Wei. A little bit small, hard to see, but hopefully it gets the point across, right? There's 3 Matic inside of this contract. Yeah, there it is, 3 Matic. Cool. So now we've confirmed that on this contract, there's 3 Matic that somebody could potentially win if they win this rock, paper, scissors game. Let's see how we put that into our front end. So this is going to be a full stack application built with the Polygon blockchain in like 5 minutes, guys. So I'm going to go over to this Web3 game.js that I have here that uses this other component called Solidity Game Engine.js. I'm very bad at naming things, which I'm sure the rest of you are too. We're all developers, right? So I have this, how do I actually go and interact with this contract, right? So I have this old contract here. Let me just delete that. Yeah. Delete that. I'm going to copy this contract address. Just so making sure, we're going to that same contract. Remember, I saved some ABI code from before. I'm importing that from ABI. What is the ABI? What does this do? Traditionally in Web 2 development, I guess, for lack of better terms, the way you would interact with an API would be through like an HTTP request, fetch, Axios, something like that, right? When you're interacting with the blockchain from a front end like React, rather than doing something like using a fetch request, this ABI code, this gigantic JSON file, essentially acts like a map for JavaScript to like parse through and understand how to interact with the blockchain. So this ABI code corresponds to the compiled bytecode from Solidity. So in order for the Ethereum virtual machine to actually read your smart contract data, that is all compiled to bytecode, which is like machine code. And that is the actual code that is deployed onto the blockchain, not your Solidity code. Your Solidity code is at a very high level. It needs to be compiled down. So this JSON file is just a map. It just tells JavaScript, okay, this is a function I can use. This is some sort of state. This is some sort of input that a function needs, etc. Right? And you'll notice in here, there's like inputs to find balance, to get the balance, etc. All the stuff that we wrote in this like nice mapped out format. So that's cool. That's great. So now we come back to our Solidity game engine again. I'm bringing in the Ethers library. Once I have the Ethers library in here, again, just some boilerplate code of just like making sure I'm connected to the contract. The contract to connection requires the contract address, which is what I had before. It requires the ABI, and it requires the signer. The signer is simply just, again, that address that we had before. Now I need to make an actual transaction, right? The transaction with the blockchain to either, check if this person is the winner or not. So I've hard-coded this to just always be one Matic. We're just always going to bet one Matic. Just keep it simple for the purposes of this, demonstration. And I have this piece of state up here. Player is winner. By default, it is set to false. And down here, again, with my very, very poorly written rock, paper, scissors game, what I'm doing here is, I'm setting, if I set the winner to be the opponent, I'm setting player to false, transacting the game, etc. And if you win, if winning is true, then transacting game will, update to be true. So you either win Somatic or you lose Somatic. So now let's go ahead and update the game. We're moving on from Web 2.5. And let's do Web 3. Okay, so I've got my React app. Let's hit connect wallet. All right. Now, I want to win some Matic, so y'all gonna need to help me. Rock, paper, scissors. Let's go. Always rock? All right, he said it first, though, so I'm gonna go with rock. All right, so this is on you if I lose money, though. All right, so let's hit rock. No, you lost me some money. All right, so hit confirm. We just lost one Matic. This is fine. Technically, yes, you could do that, if we were, making sure that this, actually worked properly, we do that on chain, which in this case you would reach for a tool like Chainlink or something like that to do like the random number generation. Here we're just, trusting our players to do the right thing. All right, let's play again. Let's try to win this time. Oh crap. Okay. Rock, paper, scissors. Anyone? Okay. He did say it first. All right, we're doing rock again. Always rock. Yes. All right. So we're gonna hit confirm. I had 494 meta. All right, it's pending. Let's see if this works. Do I speed it up? No. Yeah, that's testnet-matic, yeah. Okay, cool, it updated. I won some money. So, cool, that's a very, very basic implementation of, play-to-earn mechanics set to a browser game, right? We started off with a simple rock, paper, scissors game. We connected everything to a smart contract. It's not the most, complex application, but it's really just to give you an idea of like how you can start incorporating these play-to-earn mechanics. This is just like a simple kind of like gambling rock, paper, scissors game. But, this is kind of the basis of like what games like Axie Infinity, DeFi Kingdoms are kind of like built on. You take the little fundamentals and building blocks, put these together, make it a little bit more complex, test your code, unlike me. And always test your code. And, put that onto the blockchain and you've got a play-to-earn game. Play-to-earn is something that is getting pretty big, right now. It's all the rage, all the VC funding is trying to find its way into play-to-earn and all that. So, if that's something, I'm pretty sure it's one of the tracks as well for Polygon. So if you want to, win some money from us, something you could build. Cool, I'd like to, open this up to questions. Any questions about the code, any questions about any implementation, Polygon in general. Love to open it up to you guys. Anything? You have a question? Can we get mic? Yeah, I think he's going to give you the mic.
Great, thank you. Question was, is this code open source anywhere? Can I look at this? Maybe I want to build something similar.
Yep, so this will be open source by later tonight. So I will just post this up again. You can follow me on Twitter at Rahat Codes. I will tweet this out. But I will also put this in the Discord in like the Polygon sponsor channel as well. So both places, by later tonight, we'll have that up there.
Yeah, so I'm somewhat new to Polygon.
Okay.
I think basically how it works, right? It's like layer 2, and then all the transactions get put into Ethereum blockchain like in a bunch. That's how they can have like fast transactions and stuff, right?
Yes, so we're this specific implementation is using our Polygon proof of stake slide chain. So rather than doing like proof of work computations, which is going to take more computing power, going to take a little bit more time to do, proof of stake algorithms allow for much quicker transactions. So a lot of that is built on that side of things to get you that better UX.
So I mean Polygon offers pretty cheap fees and fast transactions.
Yep.
So does Solana. What's like the trade-offs?
I couldn't intelligently speak about Solana, so I will say, if you're already used to building on top of Ethereum, building on top of like anything EVM, the advantage here might be like you don't have to learn anything new. Like with Solana, you have to pick up Rust to build smart contracts. So if you already know Solidity, if you've already been developing on an EVM blockchain, just for developer experience, I'd go with Polygon.
Yeah. Do you know if Polygon are going to be affected by the merge? Like anything like?
Yeah, I think we're actually very happy about the merge. While we're, the proof of stake blockchain will still be a thing, will still be available. There's a whole suite of products that we're building and putting out. A combination of ZK rollups, optimistic rollups, as well as just different tools for just building on top of Ethereum. Our whole thing is just making Ethereum scalable. So whatever Ethereum does to make that easier for us is just even better. This implementation of putting this on the Polygon proof of stake blockchain is just one way you can interact with the Polygon ecosystem at large. There's only one of our products. So maybe there's a future where our other tools would be more popular because post-merge, it's probably stuff that you'd want to use. Cool. Anyone else? Did you have a question? No?
Trying to think of something.
Yeah.
Yes, about Solana, there is a tool, there is a game that exists that's called Degen Coin Flip. Okay. And what it is, it's like you bet an amount at what you want. And if you lose this amount. And if you win, you double your amount you're winning with a small fee that this contract in Solana is keeping for themselves.
Right.
Yeah. So it exists for Solana, something like this.
Yeah, I mean,
I don't know how they implemented it. But I don't know if this contract is open or not.
Yeah, I mean, this is sort of a very similar implementation. It's you're wagering some money. I could add some more to add some fees if I wanted, on top of that as well. I can code that into the balance and things like that. But this is going to be more a basic sort of implementation. But I don't think you need much to add very much more code on top of this to actually get to the end to what you were describing there. The basic functionality is there. Wagering, sending money, things like that. Probably just be doing a few things keeping track of fees and things like that.
But what they have on top is an NFT collection. Mm-hmm. That's the revenue from the percentage they are keeping. It goes to the NFTs, the wallets of the NFTs.
Nice.
Yes.
Yeah. I mean, those are definitely different functionalities you can add on top of stuff like that. That's awesome. I mean, for this, that's really for the proof of stake blockchain, cheap and fast. But our other, solutions would also leverage the Ethereum security, level of security that we have there. So yeah, I think are we out of time? Yeah. So yeah, I mean the selling points for the proof of stake blockchain is there, but if you want to leverage the full security of Ethereum and everything like that, you would reach for something like our ZK rollups, optimistic rollups, some of those other products. So it depends on your use case for what you need. Cool. Thank you for coming by to this workshop. Really appreciate y'all. Thank you for the questions, and yeah, I will post the code later on tonight. Thank you.